So two geometric figures are congruent if one of them could be placed on the other and fit exactly. So that means that if two geometric figures are congruent, they match up point for point. Every point matches up with every point in the other one. Side for side, and angle for angle. They are completely the same. They are congruent. They have the same size and shape. Okay. Every triangle has 6 parts. Every triangle has 6 parts to it. Okay? So if we look at a triangle, we'll see these 6 parts. The 6 parts are 3 angles and 3 sides. When a side or angle is shared by 2 figures, it is congruent to itself, and that is our reflexive property. Reflexive property states that any segment or angle is congruent to itself. Reflexive property. So congruent to itself would be a shortened way of expressing this reflexive property. All right, so there are, I have to admit I'm gonna lie to you a little bit right here. And I'm gonna say that there are 3 ways to prove a triangle's congruence. So let's move up over here. And these 3 ways that we're going to talk about now are the side, side, side postulate, the side angle side postulate, and the angle side angle postulate. Okay, so I said earlier that I'm, telling a little bit of a lie here, that there are 3 ways, but you'll understand what I mean in the future. So let's look at the first one. Actually, I'm going to pick a new color here. So if we look at the first one, we're saying side, side, side. So a triangle has 3 sides. If you need to build a triangle, say with 3 sticks or something, and you're given these 3 sticks, there's only one way that you can build that triangle. So given three sticks, you can only build one triangle, right? Because all the sides are going to have to be the same, and you just form a triangle, and that's the triangle that any other person would build if they were given the same set of sticks. For the second one, side angle side. So imagine you're given 2 sticks, but they're tied together at a fixed angle, okay? And if these, so let's picture this for a second. If we're given 2 sticks here, and then they're tied together at this angle, right here, and this is some distance here, and this is some distance here, there's only one other stick that could complete that triangle, right? You would have to have another stick of exactly the right length to complete the triangle. So that's why we have a side, we have an angle, and we have a side. And that proves a two triangles congruence, because there's only, if the side is the same as, if this side is the same as the other side at the corresponding side, the angle is the same as the corresponding angle, and this side is the same as the corresponding side, there's only one side left that can create this triangle. So the other triangle must be congruent to this triangle. Okay. And then if we look at the third one says angle, side, angle. Now this one's a little bit more difficult to visualize. But imagine you're given one stick, and then you're told that to complete the triangle, you have to complete the triangle by placing any size sticks on the ends, but pointing in a specific direction in 2 dimensions. So there's really only one triangle that can be formed by this idea. So if we're given some stick like this, like so, and then we're told that this is some distance, and then we're told that the other stick has to be placed at this angle here, and the third stick has to be placed at, let's say, this angle here. There's really only one triangle that could be possibly formed with these 3 sticks, given this set of constraints. And that is why we can prove 2 triangles congruence using angle, side, angle postulate.